Hey boys and girls, so today we're going to be working on lesson 9, which is lengths of chords in circles. So all we've been working on so far is degree measures, whether that degree is for an arc or the degree is for an angle. All right, today we're going to be working on the lengths of chords. We'll get to this on the next page. Let's just do a quick refresher as we look at the entire first page. All right, so if I look at the do now, it says given the diagrams of circle A, I know that they're both circle A because A is the center. We want to determine the measure of the angle. So I want to find angle X in this diagram and the arc that's labeled X. So I want to find this arc in the first diagram. All right, I know that this angle that's marked with the 74 isn't central because it's not at the center. And it's not inscribed because it's not on the circle. I know this angle that's labeled X also isn't central, and it's also not inscribed because, again, it's not at the center, it's not on the circle. So I have to use the knowledge from lesson 8, which is our interior and our exterior angle theorems. I remember from yesterday, this looks like a big plus sign. So I'm going to start out by just highlighting the segments that form that angle 74. So I can see this segment here and this segment here are forming that angle that's marked with the 74. I'm going to just highlight it here. So I know that I want to add, because it looks like a big plus sign, the arcs that the angle is intercepting. So if I follow my yellow to the right, I can see I'm hitting this arc labeled X. And if I follow the yellow to the left, I can see I'm hitting this arc labeled 62. All right, so the two arcs that I want to add are the 62 and the X. And then again, if you remember from yesterday, I have to divide by 2, and that gets me the angle, which is 74 in this case. All right, now I want to set this up like a proportion. So I know that if the left is a fraction, I want the right-hand side to look like a fraction. So any number I can always put over 1, and now I'm ready to go. So I'm going to go ahead and cross multiply on the left and the right. So I know that 74 times 2 is 148. And then I know that anything times 1 is itself. So we just get 62 plus X. And now if I want to get X by itself, I have to move the 62. So the opposite of a positive 62 is a negative. So I'm going to subtract 62 on both sides. And I can see that 86 is going to equal X. So I know that 86 would be my final answer here. All right, and I can always add it back to my diagram. That's a good habit to get into. And now if I look at the second example, it's the same thing. So the angle that's marked here is the X, right? It's that exterior angle up top. So I'm going to just do the same method that I used in example 1. I'm going to highlight the segments that are forming that angle X. So that's here and here. All right, and then I have to go back and look, well, what arcs am I intercepting? Well, I can see that I'm hitting the 35, right, because it's enclosed in the yellow at the top. And I can see that I'm hitting the 72, again, because it's in between the yellow at the bottom. And this looks like a giant minus sign. So now I'm going to take the 72 and subtract it from the 35. So I'm going to take 72, subtract it from 35, because it's arc minus arc divided by 2. And that gets me the angle. Only here, I don't know the angle, it's X. I don't have to set this up as a proportion because when I type this into my calculator, I'm just going to get the answer. So 72 minus 35, when you get your answer, and then you divide it by 2, you should be getting 18.5. All right, so 18.5 degrees would be our answer for the second. 86 degrees is our answer for the first. All right. And then if we look at the guided practice underneath, again, this is more of just like a review of everything we've been working on so far. So as I read the directions, it says determine the following arc measures given that angle EDC is 25 degrees. So I'm just going to highlight this because it's the only important piece of information that they really gave me. I'm not seeing any important keywords that I can label here. So I'm going to go ahead and mark angle EDC as being 25. So EDC, I know D is in the middle, it's the most important, so it's this angle right here that's going to be 25 degrees, and I'm just going to swoop that out here. All right, and now I kind of have to evaluate the information that they gave me maybe in the diagram, so that'll help me come up with this missing information on the side. So if you look at those line segments, CB and ED, I can see that they're marked with arrows. I'm just going to go over those in pen so it's a little clearer to see them. So I know these arrows are telling me that those line segments are parallel. All right, so I'm just going to write that on the side here, that I know that line segment CB is parallel to line segment ED. And I know that parallel lines form alternate interior angles. So I'm thinking right now that maybe if I draw a Z, that will help me in some way. So I know that I have to start on my parallel line. I have to make my way up so that I end on a parallel line. So now I can clearly see that if this angle in the green vertex is 25 degrees, I know this angle down below in this green vertex is also 25 degrees. Okay, so that helps me a little bit. I can see that I have to find arc lengths. So I know that I'm not done. Maybe I should use these angles to help me find these missing arcs all the way around. So if I look again, I can clearly see that line segment CB is not just a parallel line with ED, but it's also a diameter because it's going through the center of the circle. The center is F. So I know that the top half makes 180 degrees, and I know that the bottom half also makes 180 degrees. So I'm just going to mark that. I know this top half of the circle is 180 degrees, and I know that all three little chunks at the bottom here make 180 as well. I'm noticing that angle D is inscribed because it's on the circle. So if this angle is 25, I know this arc that it's intercepting has to be 50 because I know that the angle is half the arc. So if 50, if I take half of it, I get 25. Same thing, if this angle is 25, I know that this arc that it's intercepting has to be 50, so I'll label that. And then one more, if I look at the leftover, well, I know that everything that's in yellow here makes 180. So 50 and 50 is 100. I know that 100 plus 80 is 180. All right, I feel like we've come up with as much information here as we possibly can. So now let's look at the questions on the side. So part A asks me to find arc CE. So I can see that arc CE is 50. And then I'm just going to show the work. How did I get the 50? Well, I had to double 25. So if I take 2 and I multiply it to 25, I get 50 degrees. So that was my answer for A. If I look at B, well, what's arc BD? Well, BD was also 50, and I got it the same way. If I double 25, I get 50. So I'm just going to write that to show my work. 2 times 25 is 50. And then last but not least, if I look at C, C is arc ED. ED was 80 degrees. And we got that by saying, well, I know a semicircle has 180. And if I subtract the 50s, because that's what I know, 50 and 50 is 100, I'm left with what I didn't know, which was the 80. All right, awesome. Let's flip to the next page. All right. So if we look at example 1 on the next page, this is really like the new information for today's lesson. So I'm going to just start by reading example 1. So example 1 says determine the value of x. As I look at this diagram, I'm noticing that x is not an angle or an arc. It's a line segment. And that's what we're working on today. How do you find the length of segments in a circle? All right, well, if you notice on the entire first page, let me flip back just so you can see it. Every question that we had worked with was labeled in some way. So I can see that I have letters here, C, D, F, B, E. This diagram has letters marked. The guided practice, it was all labeled for me. And if I look at example 1, it's not labeled as of right now. And that's okay. I can either leave it that way, or I can always add my own letters so it's a little bit easier to work with. So I'm going to do that. I'm going to say that this is line segment AB, and I'm going to say that this is line segment CD. And just like in class where they intersect, I'm just going to give it a different letter, maybe E. All right, now it looks like I'm ready to go. So if I want to determine the value of X, I now want to read this information that's going to help me at the top. So it says when two chords intersect. So I'm just going to stop and highlight my two chords. I know that AB is one chord because it's inside the circle. It starts at one side and ends at the other. And I know that CD is a chord because it's inside the circle, starts at one side and ends at the other. All right, so let me keep going here. So when I have two chords that intersect, which I do, the products, I know that the keyword products tells me to multiply. It tells me that I want to multiply their segments. And when I multiply their segments, oh my gosh, I'm all over the place here. When I multiply their segments, I know that those answers should be equal. All right, so that's going to be my last keyword. They should be equal. All right, so let's start off with kind of breaking this up so it's a little bit clearer to understand what's happening, because I know this might look a little confusing right now. So when I have two chords, it's telling me that I want to multiply their segments. So if I look at this chord AB, I can break it up into little segments, AE and EB. So I want to multiply those segments. So AE, I want to multiply with EB. So again, I'm taking AB and I'm breaking it up into a little chunk at the top, which is AE, and a little chunk at the bottom, which is EB. And after I multiply those segments, I know that they're going to equal, so they're going to equal the product of the other side. All right, so now I'm going to multiply this little chunk, CE, with this little chunk, ED. All right, and then I'm just going to highlight it because you know me, love to be over the top, guys. So I'm just going to highlight that yellow little broken up chunk now because I know all of yellow was A all the way to B. So again, A all the way to B was my yellow chunks. And I know that C all the way to D was my green chunks. So C all the way to D. All right. And if you guys don't have two different color highlighters, that's fine. Do whatever you can that you think is going to help you best. All right. So this is really what I'm going to multiply to solve this type of question to get my answer. But it's not always going to be these line segments. It's not always going to be these letters. All right. So an easier way to remember this is kind of what I said before. It's like chunk times chunk equals chunk times chunk. Or you could say it's the piece times piece. It's a little piece of the top times a little piece of the bottom. And then that's going to get you a little piece on the left times a little piece on the right. Guys, get it right? Piece times piece. Okay, moving on. So now I'm going to go ahead and plug in. So I can see here that for my yellow pieces, it's 6 and X. So that's what I'm going to plug in. 6 times X. And then my green pieces are 4 and 12. So I'm going to multiply 4 and 12. All right, and then I just solve and I'm done. Whoa. So now let me set this up here. So I know that 6 times X is 6X. 4 times 12 is 48. I'm going to divide the 6 to get X by itself. And I can see that X equals 8. All right, and the question said determine the value of X. Always reread the question, and I found X, so I'm done. All right, so there's going to be 3 of these new formulas that we're going to be going over. This was just the first one. They all need to be memorized, so please make sure that you are taking the time to make an index card, you know, writing it down in your notes, whatever you got to do to have these bad boys memorized. All right, moving on to the next one. So if I look underneath at example 2, it tells me that CE is 6, so I'm going to label that. I know that CB is 9, so C all the way to B is 9. And I know that CD is 18, so C all the way to D is 18. And the question says to determine CF. So CF is this little section at the top. I'm going to label that with an X. All right. So now again, I'm going to read how I'm going to solve this question. Wow, guys, my paper is really all over the place today. I'm so sorry. Okay. It says the product. We know that product means to multiply. So it's saying if I multiply the measure of one secant segment. Well, I know that one secant segment would be CEB. So I'm going to start with that. One secant segment. CEB. And I'm going to multiply that one segment to its external part. Its external secant segment. External means outside. So what's the outside piece of CEB? You got it, just CE, because it's outside the circle. So CE would be my external piece. And it's telling me that it's going to equal, so after I multiply it to its external segment, I know that it's going to now equal the same thing on the other side. So it's going to equal when I multiply the other secant segment. So now I'm going to take the other secant segment, which is CFD. And I'm going to multiply that with its external piece. And that outside piece is CF. All right, external, it's outside the circle. All right. And then just like the first example up top, I can always shortcut this because it's not always going to be these exact letters. So up top, we said it's really like the piece times piece equals piece times piece. All right. This, I can say that CEB is the entire line segment, right? So that's going to be my whole piece. And CE was outside the circle, right? It was external, so that's my outside piece. And then it's the same thing on the other side. It was the whole piece times just the outside part. Oh my gosh, guys. Are you seeing this? What happens if I just flip these words? Your outside hole? Who is always going to remember that? It's going to be you, isn't it, right? So that's really the formula that we're going to stick with. So the top is piece times piece. The bottom is your outside hole, guys, all right? You're never going to forget it. Don't forget it, okay? So let's start plugging in and trying to solve this now. So I can see that the whole piece was 9. And the outside part was 6. Again, the whole piece was 18. And the outside piece was X. And before we solve, I just want to highlight that again because you know me loving to be over the top. So I know 9 was the whole piece. 9 was the whole piece. Same thing, 18 was the whole piece. 18 is the whole piece. And then if we go back, we have 6 was just the outside. 6 was the outside. X was the outside, X was the outside, all right? So it should be matching each time, all right? And then we're gonna go ahead and solve. So I know that 9 times 6 is 54. I know that 18 times X is 18X. When I divide 18 on both sides, I figure out that X is really just the number 3, all right? And then you always gotta reread that question, boys and girls. I wanted to find the length of CF. CF is X, and X is 3. So CF was 3. All right, moving on to the next page. Don't forget about your outside hole. Okay, whew. Almost done. Now if we look at example 3, this is the last formula that you have to memorize. So again, if I read the question here, it says I want to determine the value of X. All right, so I'm going to start off by now going over what this really is representing as far as the question goes. So as I'm reading, it says the product. So we know product means to multiply. So it's telling me that I want to multiply the measure of a tangent segment. So I want to multiply the measures of a tangent segment. Well, the only segment here that's tangent is BC. Because a tangent segment hits the circle, you got it one time. So it touches the circle one time. and it's only touching it CB here, right, that one time. So it says I want to multiply the measures, so that's plural. So I want to take this segment CB and I want to multiply it to itself. I want to multiply it 2 times. So I'm going to take CB and I'm going to just square it because I want to multiply it to itself. And then I know that that's going to equal, it's going to equal, all right, the product. So I'm going to multiply again, the product of the secant segment. Well, I know that this CED is my secant segment because it comes right out the circle. So CED. So I want to multiply my secant segment to its external part. All right, and we already learned from the last question, external means outside. The outside part of CED is just CE. All right, CE. And now I'm going to go ahead and try to come up with another formula here that's easy to remember. So CB is the outside section, right? It's external, outside the circle. So I'm going to write this as my outside piece squared. And then I can see that CED is an entire segment, so that's my whole piece, times CE. And again, CE is just outside the circle. So on the last question, it was your outside hole times your outside hole. This question is just a little bit different. I have my outside hole, but over here I don't. I just have the outside. So I'm just going to multiply it to itself. All right. And then from here, we'll go ahead and plug in and try to solve. So the outside squared, this is the only section that's outside. So it's the x plus 3. Always using parentheses when you plug in, guys. All right. It has to be written like this. So it's x plus 3 in parentheses squared equals the whole segment. The whole segment would be x plus 7. Because I don't know what this is, but I'd have to add them together to get the whole section. So I'm just going to write that in over here, x plus 7. So the whole chunk is x plus 7. And then the outside piece was just x. And now I'm going to go ahead and try to plug it in and solve. So this x plus 3 squared, I'm just going to try to give myself some room to rewrite it up top. It's really like saying I have x plus 3 times x plus 3, okay? This is from Algebra 1, so just kind of go with me right now. And then you'd have to distribute to solve this, all right? So I would have done x times its neighbors, which are x and 3. And then I would have gone back and done it again, only with 3 times its neighbors, which are x and 3, all right? When you multiply all that up, you get x squared plus 6x plus 9 for the left-hand side. And then I'm going to do it again over here. I'm going to multiply x to its neighbor, which is x, right? So x times x is x squared. And then I'm going to do it again. 7 times his neighbor, which is going to be 7x when I multiply, all right? If I try to combine like terms like these x squareds, because they're on opposite sides, well, a positive x squared is going to move over and become a negative x squared, all right? X squared minus x squared is 0. So I'm just going to cancel these out right now, all right? And that's something you can always do. When you have the same term on both sides of an equation, they're just going to cancel, all right? And then if we keep going, now all I have left is the 6x plus 9 equals 7x. All right, now I'm going to keep solving. So I'm going to combine my x's onto one side. So I'm going to move the smaller number, which is the 6x, to the bigger number, which is the 7x. When I subtract, I'm just left with the number 9. And 7 minus 6 is 1. So I'm just left with that x equals 9. Now I have to go back and reread the question. It says determine the value of x. I know that x is 9, so I'm done. I found my answer. All right. And now example 4 is you trying to decide what formula you should be using to solve this question. All right, so there's 3 formulas you've learned. Piece times piece, piece times piece. Outside hole, outside hole. And then the last one is what we just worked on. Outside hole, but then it's just multiplied with the outside squared. All right, so as we look at example 4, I'm going to read this through. So it says, in the diagram below, PA is tangent. All right, so I'm going to just highlight that because I know it's a key word. So I know I have a tangent line. It only hits the circle one time, so PA is tangent. And so it's tangent to circle T. T is the center at A, so it's tangent at A. Sorry guys, kind of a lot of information here. We have secant PBC. So I know this is a secant because it goes right through the circle and it's drawn to point B on circle T. Again, T is the center. Now we're getting to the good stuff. So if I know that PB is 3, so this little chunk is 3, and I know that BC is 15, so BC is 15, determine the length of PA. So PA is what I want. This is what I'm going to make X. All right. I don't know if this is going to be my outside hole equals my outside hole, because if I look here, I have an outside and I have a hole. But if I look at the other segment, I just have the outside. So this looks just like example 3. So this is the formula that I want to use to solve. All right, so it's going to be my outside squared equals my outside hole. All right, and now I'm just going to kind of plug in and solve. So again, it's my outside squared. PA is the only outside here, so I'm going to square X. So it's my outside squared equals, all right, so we know that CP, the whole piece, is 18, so it's going to be my outside hole. So my outside is 3, my hole is 18. So again, my outside is 3, my hole is 18. All right, and then I just kind of solve from there. So I know that X squared equals 54. Right, 18 times 3 is 54. And then to get rid of that exponent 2, I have to square both sides. Oops, I lied. Take the square root of both sides. And now I know that X equals the square root of 54. All right, this is not a perfect square, so it doesn't simplify. It doesn't say anywhere, you know, simplest radical form, so I'm good to just stop right here. All right, please make sure you guys are watching the videos every day during the week and submitting all of those assignments on time. Miss you, love you. Email us if you need any help.